Assalamualaikum and a very good morning to the audience. I am Dr. Khairunisa Muthusamy from Faculty of Civil Engineering Technology, University Malaysia Pahang. Today, I would like to share findings that we have discovered from the research that we have carried out. The title of the research is The Effect of Ground Cockle Shell Ash as Partial Cement Replacement on Compressive Strength of Morta. Before I move to the presentation, I would like to present the content of this presentation. So we begin with the introduction, followed by the problem statement, research objectives, the methods that have been used to achieve the objective, results, and finally conclusion. The growing construction industry, along with the expanding population, consume high amount of resources, and this causes environmental problem. Concrete is one of the widely used construction material in the world. Cement industry, which contribute to the growing concrete industry, also pose negative impact to the environment. These industries also generates waste, which have negative impact to the environment. Other than that, aquaculture industry, which produces high amount of waste, also causes environmental pollution. In relation to that, disposal of cockle shell waste from local fisheries industry causes environmental pollution and disturb the living comfort of community nearby. Success in transforming this waste into construction material would be beneficial to the environment as well as community. As we can see here, the construction industry, which continue to rise, results in increasing production of cement. Cement industry consume high amount of raw materials from the green environment. The harvesting of these raw materials destroy the environment. Excessive harvesting would cause destructive effect to our environment, which finally would have negative impact to our future generation. Other than that, cement industry also consider a high CO2 emission industry. Use of waste material as partial cement replacement would contribute in reducing cement consumption and pollution issue caused by cement industry. Other than that, the cockle trade is generating waste known as cockle shell. The disposal of cockle shell at dump site causes environmental pollution, and it also causes discomfort to the community nearby. Success in utilizing this cockle shell as cement replacement would reduce waste thrown at landfill and also creates cleaner environment. Therefore, in this research, the effect of ground cockle shell ash as partial cement replacement on flowability of fresh mortar has been investigated. Other than that, the effect of ground cockle shell as partial cement replacement on compressive strength of mortar has also been determined. In order to achieve the research objectives, specimens have been prepared by using some mixing ingredients. Among the mixing ingredients that have been used in this preparation of mortar are cement, water, sand, and cockle shell. Cockle shell has been collected from the dump site. Then it has been washed with clean water and then oven dried before it is burned under high temperature. And finally, it is ground until it's become a fine powdery ash. This is the chemical composition of cockle shell. The quantity of calcium oxide in cockle shell ash is higher than limestone. A total of 7 mortar mixes has been prepared. Plain mortar mixes containing 100% ordinary Portland cement has been prepared as a control specimen. Other mortar mixes were prepared by varying the percentage of cockle shell ash, beginning from 0% up to 60%. Two types of testing has been conducted to achieve the research objectives. In order to determine the effect of cockle shell ash on flowability of mortar, flow table test has been conducted. The test has been conducted in accordance to ASTM 1437. The compressive strength test has been conducted to determine the effect of cockle shell ash on compressive strength of mortar. The testing has been conducted on hardened mortar cubes. All the specimen has been subjected to water curing for 28 days before the compressive strength test is conducted. Based on the testing that has been conducted, for the flow table testing results, it can be observed that the use of cockle shell ash as partial cement replacement results in the increase of flow dispersion. As we can see here, the flow dispersion become higher as larger percentage of cockle shell ash is used as partial cement replacement. Mixture containing 60% cockle shell ash has the maximum flowability value. Similar pattern has been reported by past researchers who use different type of seashell as partial cement replacement in mortar. As for the compressive strength test result, the use of 10% cockle shell ash able to produce mortar with enhanced strength. The use of finer sized cockle shell ash as compared to cement produces mortar with denser internal structure, which contribute to strength enhancement. However, excessive use of cockle shell ash results in strength declination. Similar pattern has been reported by previous researcher, Tae et al. 2020. As for the conclusion, from the findings, it can be deduced that the use of cockle shell ash as partial cement replacement increases the flowability of mortar. The use of suitable percentage of cockle shell ash, which is 10%, successfully increases the compressive strength of mortar. Using too much of cockle shell ash as partial cement replacement results in compressive strength declination. The use of cockle shell ash for construction material production would reduce the shell waste which disposed at landfill and contribute to cleaner environment. With that, I end my presentation. Thank you.